All right, so the end product of what we're going to look at today is going to be this chart, which is going to be all the different things that are true about the quadrilaterals that we're going to be looking at. But before we fill all that out, we're going to look at some background information and point out a couple things about all of these different shapes. So, backing up, we're going to start with what's familiar to us, which is our parallelograms. So you should know all the properties that I'm about to show you here, but we're going to break this down a little bit. First off, parallelograms have both pairs of sides being parallel. So here's both pairs of sides being parallel because both of these segments have the same slope. C to D and A to B have the same slope, so they're parallel. And D to A and B to C have the same slope, so they're parallel. Not only that, but we also have all of our different properties of a parallelogram. We've got both pairs of opposite sides being congruent. We have both pairs of opposite angles being congruent. So angle A and angle C are both 127 degrees. And then angle B and angle D are both 53 degrees. So there's my opposite angles being congruent. You'll notice 53 and 127 add to 180. So those are supplementary. Then over here, you'll notice that the diagonals are bisecting each other. A to E and E to C are both the same. So that diagonal is getting split in half. And then B to E and E to D are the same. And the other diagonal's getting split in half. There's some other measurements here, but they'll come more in handy with the next problems that we're going to look at, the next shapes that we're going to look at. So there's all of our properties of a parallelogram. Now keep an eye as we go through, keep an eye on these slopes, because one of the questions that we're going to ask with each shape is, do we have a parallelogram or not? And that question really is, are those pairs of slopes the same or not? So keep an eye on that as we move on to our rectangle. And the thing that makes this a rectangle, I will start with that, is all these angles. Remember that a quadrilateral, any four-sided shape, the measurements add up to 360 degrees. So if all the angles are the same, which needs to happen in a rectangle, that leaves 90 apiece. And then notice that we have a parallelogram because those opposite sides have the same slope to them. So because they have the same slope, we know those are parallel, so we know that we have a parallelogram. And so all the things that were true about a parallelogram are going to be true about this rectangle. You'll notice that the opposite sides are congruent, both 3 and both 6. You'll notice that the diagonals bisect each other. But a new thing is happening with the diagonals, which is that the diagonals are congruent here. These diagonals are congruent. In other words, A to C, the entire diagonal, and B to D measure the same. They're both 6.7. So the diagonals are congruent. That's kind of the new piece that is true about a rectangle on top of all the angles are 90. So there's our rectangle. The next one we're going to look at is a rhombus. Notice a rhombus doesn't have the right angles. Notice that a rhombus is a parallelogram. Slopes are the same. C to D and A to B are parallel, and so are D to A and B to C. They're parallel. But here's the part that makes it a rhombus, is our side lengths here. They're all 5. They're all the same. So all 4 sides are the same. That's what makes it a rhombus. That's our definition of a rhombus. And you'll notice one other thing happens here in our rhombus. is angle BEC. Notice that that angle is 90 degrees, this angle right here. And so that makes the diagonals, if they make a 90-degree angle, that makes them perpendicular, because that's what it means to make a 90-degree angle. Our diagonals are perpendicular. So that's the new part for the rhombus. And you'll notice the diagonals are not congruent this time. A to C and B to D are not the same, but the diagonals do bisect each other, just like they do in any parallelogram. Now let's talk about our square. Our square, you'll notice that all of these things are true. And the thing that makes it a square is that it's a combination of my rhombus and my rectangle. All the sides are the same and all the angles are the same. You'll notice that it's a parallelogram because the slopes here are the same. You'll notice that all the things that were true about the rhombus and all the things that were true about the rectangle and all the things that were true about the parallelogram, they're all going to be true here. The diagonals are going to be congruent. The diagonals are going to be perpendicular. They're going to all bisect each other. All the sides the same, all the angles the same. That's what makes it a square. So far, we have our parallelogram that we're familiar with. We have our rectangle where all the angles are the same. We have our rhombus where all the sides were the same. And then we had our square where both happen. All the sides are the same and all the angles are the same. So let me pause here and go back to the chart. And we'll talk about the kite and the trapezoid in just a minute. But I want to focus on the first four. Notice we said the first four so far are all parallelograms. I put a DEF whenever it's the definition. So both pairs of opposite sides are parallel. That's the definition of a parallelogram. So I put a DEF there. Going a little bit further down, all the sides are congruent right here. That's our definition of a rhombus. So I put a little DEF where that's the definition of a rhombus. All the angles are congruent is definition of a rectangle. And then both of them are my definition of a square. So in blue here are all the things that are true about a parallelogram. So we have our opposite sides congruent, opposite angles congruent. The consecutive angles are supplementary and the diagonals bisect each other. Those things are all in blue because they're all things that are true about a parallelogram. Then in red, we have all the things that are true about a rectangle. And because they're true about a rectangle, they're also going to be true about a square. And over in green, we have all the things that are true about a rhombus. And anything that's true about a rhombus is also going to be true about a square. So we have all these things that are true, and when we get into more specific shapes, those things are still going to be true about those more specific shapes. Anything that's true about a parallelogram, it's going to be true about a rectangle, because a rectangle is a more specific kind of parallelogram. Then square has the most things going on in it because it's a very specific type of shape. That's why going forward here, you're going to see me ask for what is the most specific type of shape. Because the more specific we can get, the more things we can say about it. And the more measurements we're going to be able to find. But enough about parallelograms. Let's move on and talk about the kite. The kite, you'll notice, is not a parallelogram. It is not a parallelogram because these sides are not parallel. Here's C to D. The side across from it is A to B. And those slopes are not the same, so the sides are not parallel. So the things that were true about a parallelogram Not going to be true about my kite. The thing that is true about the kite, the thing that makes it a kite, is the consecutive sides being congruent. That's the definition of a kite. The consecutive sides are congruent. So that's happening right here. A to B and B to C are congruent. And C to D and A to D are congruent. Those pairs of sides being the same is what makes it a kite. Then you'll notice a couple things that we're going to mark off in our chart. First off, angle A and angle C are congruent. So these opposite angles are matching. You'll also notice that we once again have our diagonals being perpendicular to each other, making a 90-degree angle. And the last thing you'll notice here is that one of the diagonals are bisected. A to E and E to C are the same. And again, remember, that's different from the parallelogram, where both of the diagonals were bisected, split in half. This time it's just one of them. A to E and E to C. So those are all the things that are true about a kite. You have one diagonal getting bisected. You have one pair of angles being congruent. And you have the diagonals being perpendicular. Now, over in our trapezoid, what makes it a trapezoid? Well, the thing that makes it a trapezoid is that we have one pair of sides being parallel, which is this pair of sides right here. That pair of sides is parallel. The other pair of sides is not parallel. They don't have the same slope. So these sides are parallel. The other pair of sides are not. And the thing you'll see is that in this isosceles trapezoid, the thing that makes it isosceles is that the other pair of sides are congruent to each other. So A to B and C to D are the same. So this trapezoid is isosceles. And the main thing that happens when the trapezoid is isosceles, well, two things. Thing number one that happens is that these angles become matching. So the base angles, just like in an isosceles triangle, the base angles are congruent. In an isosceles trapezoid, the base angles are also congruent. And then thing number two that happens in an isosceles trapezoid is right here. Those diagonals, just like in a rectangle, those diagonals end up being congruent. So, back to our chart. We're going to finish it up here. Notice that the kite and the trapezoid are separated off. That's because they're not parallelograms. So they don't have all the properties of all the other shapes that we've talked about. First off, the kite. The kite has the diagonals being perpendicular. The consecutive sides are congruent is the definition of a kite. And then we talked about the opposite angles being congruent. Up here in the trapezoid, the only thing to make note of is that the diagonals being congruent, this part in parentheses means that this is only true if the trapezoid is isosceles. Otherwise, it's not true. And then, of course, our definition, our DEF, second box down, exactly one pair of opposite sides are parallel. That's what makes it a trapezoid. Trapezoid is isosceles if the two pairs are the same. So to give a little summary of what you're seeing, here are all your different quadrilaterals, from most general name to most specific name, to when we can say the most amount of things about it. First off, if all we know is that it has four sides and we don't know any other information or it doesn't fit any of our categories, we're going to call it just a quadrilateral. Then, over here we have our kites, where the consecutive sides are congruent. Over here we have our trapezoids, where one pair of sides are parallel. Then in the middle here we have all the parallelograms. And more specifically, if we have all four sides the same, it's a rhombus. If we have all four angles the same, it's a rectangle. And if we have both of those being true, all the sides and all the angles, then it's a square. So notice that some of these are more specific. Go lower down, they're more specific, and we can say more things about them. And just to give one more visual of what this looks like. Out in the white section here, we have the general quadrilaterals, where all we notice that it has four sides and it doesn't fit in any of our categories. In blue are the trapezoids. Some of those trapezoids are isosceles. Over in red, we have the kites. And in green, we have our parallelograms. Some of them are just parallelograms. If we know all the angles are the same, then they're rectangles. If we know all the sides are the same, then it's a rhombus. And if we know both, then it's a square. So another way to think about a square is that a square is a rectangle that is also a rhombus. Rectangle, all four angles are the same. Rhombus, all four sides are the same. So if you have both of them happening, then it's a square. So next time we'll actually look at examples where we use these properties. But that is the main chart that we're going to be using throughout this chapter to talk about these different types of shapes.